Welcome back, students. This is the session 16 from the playlist of laws of motion. The topic is constraint motion, and today I will be um, explaining this topic with the help of a simple example. And for that purpose, I have drawn one figure here. In this figure, there are two fixed pulleys. They are supported by a rigid support as shown in this figure, and these two are the movable pulleys, and two bodies of mass m1 and m2, they are attached to these movable pulleys as shown in this figure. And these four pulleys, they are attached to each other with the help of this string, one end of which is connected to a rigid support and the other end is connected to a body of mass m3. Now, when this body of mass m3 moves in the downward direction, what will happen? These two bodies will move in the upward direction. And if this body moves in the upward direction, then these two bodies will move in the downward direction. Or we can, in other words, we can say that the motion of these two bodies is getting restricted either in the upward direction or in the downward direction. So, whenever the free motion of a body is constrained by some external means, then the motion is said to be constrained. So here the motion of these two bodies is getting constrained in the either in the upward direction or in the downward direction, and this constrained motion is happening because of this arrangement of pulley. So this is the basic definition of the constrained motion, that is, whenever the free motion of an object is constrained by some external means, then the motion is said to be constrained. And I have tried to explain you here with the help of this very simple example. Now, here what I have done is, I have taken these are the three bodies which are M1 and M2 are the two bodies which are attached to these two movable pulleys, and M3 is a body which is attached to one end of this string. The other end of the string is connected to this rigid support, and this entire system is connected to each other with the help of this string. Now, since there is only one string here, so the tension in each and every segment of the string will be the same. That is, tension in this part will be T, the tension in this part of this string will also be T, in this part it will be T, and in this part it will be T. So the tension in all the segments of the string will be the same, so which I have taken here as capital T. Here I have taken the acceleration of this mass m1 as a1, the acceleration of this mass this body of mass m2 as a2, and the acceleration of this body having a mass m3 as a3. Now, the most important point here with regards to the constraint motion is written on this board here. That is, in the constraint motion, the algebraic sum of the product of all the tensions in the strings and the velocity of all the bodies connected to those strings is 0. That is, summation T into V will be equal to 0. Now, algebraic sum means that we have actually one more thing. Since this summation T into V is equal to 0, so this can also be written as this summation T into A will be equal to 0, because if I differentiate this equation with respect to T, I will be getting this equation. That is, summation T into A will be equal to 0. So, the algebraic sum of the product of all the tension in the strings and the velocity of all the bodies, or the acceleration of all the bodies connected to those strings is 0. And this equation, we have got this equation from this equation, because if I differentiate this equation with respect to T, I will be getting this summation T into A will be equal to 0. Okay? So this is one important equation, and in the next important equation is this one. That is, the net force acting on these bodies will be equal to M into A. So using these two equations, you will be able to solve the numerical problems based on this topic of constraint motion. And the most important thing here, again, which I have not mentioned, or which I want to discuss, is the term algebraic sum. Algebraic sum means, that is, if the acceleration of this body, let us say, if I am taking the acceleration of this body m, this having a mass m3 is a3, then the acceleration of these two bodies will be negative, because if this is moving downward, these two bodies will be moving in the upward direction. So the direction is opposite to each other. So if a3 is positive, then a1 and a2 will be negative. So the first important expression or equation which we will be using while solving the problems related to constraint motion is summation T into A is equal to 0, and the net force acting on the bodies will be equal to M into A. So in the next session, I will be taking up one question based on this topic, and till then, have a nice day. Bye.